We're here at Holly Hill Mall in Burlington, North Carolina for the Burlington Mini Maker Faire. Welcome to Hack a Week. We're getting set up here with our display for Hack a Week. In the midst of doing all that, we just got here a little while ago. Other people have already gotten set up. So we're gonna get everything going, and then we're gonna take a walk around after a while and see who else is here. Should be a fun day. Okay, Burlington Mini Maker Faire is up and running. Let's get started right here.
Hi, how are you?
Good, how you doing?
Good.
Tell me a little about yourself. What does you do here?
Well, I'm a native of Alamance County, but I've worked in the film industry for over 30-some years, and we produce a large haunted house attraction called the Original Hollywood Horror Show.
Okay.
We're makeup artists and film producers, and this is some of the things we've worked on. We've done lots of TV shows, movies, and we produce movies locally.
Let's take a look at some of the stuff you've done here.
This is from a Star Trek episode. We won an Emmy for that makeup. This is from Day of the Dead. This is one of the production companies. This is a Tom Cruise bust. Lots of things. This is the movie we shot here in this area. Actually, we shot a scene from the here in the mall that was in the movie. It's in the movie.
Wow.
We shot it right over there.
Creepy. Really nice work.
Thank you.
All right, thanks a lot.
Thank you. Appreciate it.
Hi, I'm Robbie Stanley from Discovery Place in Charlotte, North Carolina, and we're here today demonstrating at least about 3 or 4 different projects that we do at Discovery Place.
So what's the one that's here? It kind of reminds me of my spirograph I had as a kid.
That's what I call it. This is a record player spirograph.
It's great.
And it's actually designed to make fancy parametric curves, and by even changing one bolt or by changing the relative speed of the tube, you can make, as you can tell here, extremely different designs over the course of just a few moments. And I've designed this myself. I've run it a number of times, and I never see the same pattern
I'll
twice.
bet. Yeah, it's great. And what else you got going on?
Well, later on, I'll be demonstrating this compressed air rocket shooter that I designed.
Great.
So we'll crank this thing up to about 30 or 40 PSI and fabricate some simple rockets out of typing paper and duct tape and send this thing flying.
Cool. The power of air.
That's right.
All right.
Over there. I don't know if you want to go over there and restart it or something. Or
Yeah, I saw this earlier. It's the catapult for the cornhole game, huh?
Yeah, this is our catapult cornhole.
Great.
I designed this catapult so that we can talk about elastic and gravitational potential energy. We've got it set up for elastic right now.
That's great.
People love it. And right over here, I'm giving people a chance to try a little bit of carving.
Oh, way cool.
So I'm showing people how they can take simple linoleum tiles, scrap tiles, and Dremel, and have a lot of fun. So here's just some samples.
Nice. And you can do printings with these.
Exactly,
Wood
yeah.
blocks, yeah.
Yeah, that's right. We'll show people how you can do block printing and all different kind of stuff.
I just recently picked up some of this stuff. I'm going to do some myself again.
Yeah, it's a lot of fun.
It is.
And I also want to invite everybody to come out to the Charlotte Mini Maker Faire. I organize that in Charlotte, North Carolina. It's coming up October 8th.
Great.
So if you love maker fairs and you want to see tons of stuff, come to the Charlotte Mini Maker Faire, October 8th.
Cool. I'll have to see if I can make it down there.
All right.
All right. Thank you.
Thank you.
Steve Wisniewski, my company's Wish Bass. I make inexpensive musical instruments because I know how much musical instrument players make, which is nothing. And these are all handmade.
Beautiful.
Kind of exotic, alternative woods.
Real curious about this one down here because I'm a bass player.
Oh, you can take this home, real reason. This is like an experiment.
It's pretty neat.
It works.
It's a lot of fun to experiment
I call
with
it the
sound,
hacker
though.
bass.
It's got a pretty cool look. I like it.
Take out on a festival. Hell out of it.
Yeah. And what kind of woods do you use on some of these other ones here?
Let's see, cedar, that's western cedar, that's old growth poplar out of a cabin. Let's see, this is let's see there, lacewood and butternut or cherry I guess. Just all kinds. I like domestics.
And the one he's playing back here, you made this?
Yeah, that's what my shop burned down a year ago, and that's a sill. The only thing that didn't burn to the ground was treated pine sill.
Amazing.
So you can see the burn mark.
Yeah, that's great. All right, really nice work.
Thank you.
Hi, I'm Elliot Inman, and this is Musical Circuits. We're doing a couple things in the makerspace here today, the Burlington Mini Maker Faire. We have an Arduino that's connected up to feed MIDI information. It includes a sequencer to sequence the sounds.
That's cool.
We also have some circuit drawing, completing the circuit using the pencil to connect the circuit, using a simple hex inverting CMOS chip that will connect up.
Nice.
And you can see a demonstration of this online at musicalcircuits.com.
Cool.
Yep.
Yeah, it's fun stuff. I like making things too that, you know, synthesizer type stuff. It's easy. I do a lot of stuff with 555 square wave output. It's kind of harsh on the ears, but
well, sound is a great way to experience it, so you realize what the circuit is doing. It's a beautiful way to understand it.
I've been wanting to do the what's everybody calling it, the Punk console, the Atari Punk console. That might be fun. Thank you very much.
Thank you.
And who's this? Well, it's HackaweekTV. Yeah, we've got it all set up here. People have been coming around all morning, playing around with stuff, especially the kids. They just love all the things you can touch and feel. That's what's fun about the HackaweekTV display. It's always touchy-feely stuff. Got the old Whack-A-Mouse still in action. It had to be rebuilt once. That little switch right there in the center finally gave up the ghost after probably a million+ cycles, but still working, still taking abuse from small children everywhere. Got the robots here. Got the creepy doll that we made. It's yet another iteration of the creepy doll. Cool. Nice shirt. HackaweekTV visitors have great taste. So Lisa dressed up the doll. I redid her at the last minute. Stuck a little tripod down there for some feet. And this is from the tube amp. The tube amp fried when we fired it up here. The transformer decided to short out and magic smoke came out, and well, that's all. No more sound comes out. Got the squonk box here. People love playing with that. So that's the HackaweekTV display. Outside now in the parking lot, getting ready to do the balloon launch, and it's almost time.
Get in front of it where it's going to land and recover it. Let's stop at 11. All right. Stand by. That's 11. All right. Remember what you were doing with the tape last time? Grab that tape. I'm going to pull this off. You slam the tape over the nozzle. And go. Okay. Now, what we want is keep your hands away a little bit. We're going to check buoyancy. Not quite positively buoyant. So we're going to do a little bit more. Okay, ready to pull the tape off? Okay, go ahead and fill. Wow, almost neutral. That's nice. Dark close to neutral. That's nice. Let's call it there. Hang on, you want me to? Yeah. 5, 4, 3, 2, 1, launch! Just this side. That's successful.
It's gone.
guys want it? It's over here.
Okay, again, we're looking at a landing somewhere around Cary, North Carolina.
I'm Julie Heron. I work under the artist Heron. It's my company for my personal paintings, illustration, and design work.
And what is it you're doing here?
I'm selling most of my prints of my work. I'm displaying like my paintings and doing a demonstration of how I work.
Great.
Hi, I'm Kelsey Leonard and I'm part of the Helping Hands Project. We are a nonprofit organization that makes 3D prosthetic hands for kids. We make these with 3D printers. So what they would do, this would be for a child that was missing fingers. If they were to bend their wrist, they could get this motion back.
Wow.
So if you,
Just by bending a wrist.
just by bending the wrist.
That's
so
great.
they could actually pick things up just by bending their wrist. As you can imagine, if you didn't have fingers, it'd be very hard to pick up something like this with that hand. And we also have the same thing, but in the forearm version. So if they were to bend their elbow, they could
Wow.
also get that to work.
That's great.
And we try to make these as custom as possible. So this is actually for an actual child. These two are models. This one's for an actual child. He outgrew it. So he actually had two fingers, these two fingers. And if he would bend his wrist, he could still get these three.
That's great. Super innovative.
Yeah. So we make these so that these kids, you know, the prosthetics that you've seen that come from the doctors, those tend to be thousands of dollars. Whereas this would cost about $40 to make.
Wow.
And because we run off of donations, we're able to give these to these kids for free.
That's
and you know,
that's
kids,
excellent.
they like bang stuff around.
Sure.
Not gentle by any stretch of the imagination. So,
I can attest to that. I've
Yeah,
broken my arms
so-
3 times.
yeah, so maybe they were messing around the driveway, left it in the driveway, maybe Rom ran over it with the car.
Yeah.
Well, you just give us a call and we'll give you another one.
That
and then
is
maybe
excellent.
you hit a growth spurt and you need another one, we got you too. So,
That's cool.
Yeah.
That's a really good use for 3D printers too, because I see a lot of them get used just for trinkets and whatnot. But
Yes.
it's great to see them be used for something like this.
Yeah, and if one was to break, all of this, the rest of this hardware, you could find at your local hardware store.
Yeah.
Maybe just minus this, but I mean, you have fishing wire, you have screws.
Do you release any of this open source where people can print their own?
So these are all actually already online. So this is totally an open source design.
Great. That's
so,
great.
I think it's on Thingiverse is where you can find
Yep.
the files.
Okay.
Yeah, so if you have a 3D printer, you can go ahead and print out one of these.
All right.
So.
And people can make donations at that address right there.
Yep. And if you're an engineer and you wanted to help out, maybe donate some parts, we have a link on there for you to find the link for the parts.
All right.
Yeah, just give us an email, shoot us an email, let us know if you want to get involved, and we'd be happy to have any help we can get.
All right. Thanks a lot.
Hi, I'm Jenna Rice. I'm the Program Director of Alamance Arts in Graham. We're the Arts Council for Alamance County. We support and promote the arts throughout the county, no matter what it is. And today we have a little exhibit of puzzle pieces made with dry erase board, so kids can color on it, or even adults if you like, and create a sculpture as you see behind you. And
Wow.
yeah, so that's kind of what we're doing, showing how art can be very interactive and also kind of tie into the whole engineering aspect of the makers movement.
That's great. Art
We're
is
happy to be
engineering in
here.
a way. All
Very
right.
happy to be here.
Thanks a lot.
Thank you.
Hi, I'm Rosalind Lockett, and I'm the Center Director for Sylvan in Greensboro.
And I'm Amy Tucker. I am the Center Director for Sylvan in Winston-Salem. And we have got our STEM courses set up. So
Right.
we've got robotics, which you can see our Ferris wheel going around. We've got engineering with the bridges over here.
Nice.
And then we also do some video game design classes with students.
Excellent. Engineering's a good thing to get kids started in early.
Absolutely.
Yeah. I got started with Tinker Toys.
Yep.
Tinker Toys and bricks, those plastic bricks before Legos. Yeah.
Yes.
All right. Well, thanks a lot.
Thank you.
Hi, I'm Shannon. Sheila with Bricks for Kids. We teach science, technology, engineering, arts, and math using Lego bricks. So we have camps and birthday parties, after school programs, and in all our camps you would learn how to do Technic builds, you'd learn how to do sculpting, learn how to do mosaics, and then we do crafts. But we also have robotics and movie making. This is creative play. This is something that somebody built. We have all kinds of themed camps, Minecraft, Ninja Turtles. This is Star Wars camp. This is our Lego Labyrinth.
Wow.
Here's our mosaic station. But we have Bricks for God. We have massive curriculum, preschool curriculum. So come and join us. We'd love to have you. Have a blast, learn to create.
You gotta love the crossover between Minecraft and Legos.
Oh yeah.
And you know, the funny thing to me I've noticed about that game is it's could potentially, people that get into it at a young age, it would spawn a career in engineering.
Oh, completely.
Totally, because there's so much stuff in there you build.
The educational value is astounding because I had to play it to teach it.
Yeah, which is excellent for a video game, right?
Yeah, so the same with movie making. You can come to our movie making camp and become a movie maker.
That's cool.
So we want it accessible for everybody. We want everybody to have a blast.
Well, thank you.
You're welcome.
I'm Julie Budd, and I'm the Outreach Coordinator for Crossroads for the Sexual Assault Response and Resource Center, and we have been wanting people to write messages of support to go on our quilt that's going to Washington, D.C. to be a part of a national monument to sexual assault survivors. So people are writing their own stories or they're writing messages of support. So in 2017, these will go on to the Washington Mall, and it will spell out, all of the red squares will spell out "not alone."
That is great. All right,
Want to
thank
do
you.
it, guys? Yes. Here, what color you want? Okay. You want yellow?
I'm Cody Keller. I'm a high school student at Wake Forest High School. I'm a 12th grade, and I created a nuclear fusion here.
And it was in Make Magazine, I see.
Yes, it was.
That's pretty cool. Tell me a little bit about it.
So we have a high energy process coming along here, and we depressurize the inside of the chamber. And when we turn it on to the high voltage power supply, and we take out all the air and we turn it on, it creates a chain reaction, putting atoms together and stuff like that, causing a chain reaction to do a ball of energy, as you can see right here.
So it's basically nuclear fusion on a very small scale.
Very, very small scale, yeah.
Yep. Well, that's pretty cool. I'm curious what you salvage the high power power supply out of.
That's an ozone power supply.
It is?
Ozone generator power
Yes.
supply.
Okay.
9,000, 7,000, 9,000 volts.
Great.
And it's variable frequency. So you can change the frequency of the output, and it changes the effect on the grid there.
That's excellent.
That's kind of cool.
All right, thanks a lot.
Thank you.
Richard McWhorter, and I'm kind of retired, and I have about 3 jobs right now. One of them is taking care of 3 radio stations.
Oh.
They have Truth Broadcasting. One in Durham, Raleigh, and Butner is the other one. And the display here this year is the theremin.
Very nice.
And the kids can see their voice here.
And it's up right now. Hello, there it is. There's the waveform on the scope. Nice.
And this is how everything is stored. I'll hook up the, there we go. Hook up the phone here. I'll reset it. Bulb test. And now when I dial a 10, 2 and 8.
Great.
That's how things are stored. I'll dial another 10. 20, of course. And so on.
Really cool. All in binary.
Yep. And that's how things are actually stored. Once you get way down to it, you can't go down any farther.
Right.
That's it.
It's all ones and zeros.
Yep. It's amazing.
It is.
All the video, well, absolutely everything.
Everything digital that we deal with every day.
Yep.
Yeah, none of it's real.
Nope.
Well, it is as soon as you run it through a device to be able to extrapolate it back out.
Yep.
So, all right. Well, thank you very much.
Oh, you're welcome.
So we're a first robotics team, which means that we get 6 weeks to build a robot for Pete. And this is our robot from a few years ago. The game was to shoot basketballs, and what it had to do was over there had to shoot basketballs into that with 5 other robots on the field, and they played a game. And we get a new challenge each year.
I saw it shooting them earlier. It wasn't doing too bad.
No.
Looks like there's a lot of work went into putting this thing together too.
Yeah, it takes a lot of work. All hands on deck. We have a bigger team, which makes it a little bit easier.
Yeah.
Yeah, we have 40 people on the team.
Wow, that's a lot.
We're at a high school.
Yep, that's great.
Thank you.
All right, thank you very much.
Yeah.
Hello, I'm Joshua Fitzgerald. I have created and 3D print this invention called H-lock connectors. They're like Legos, except they work on a hinge rather than on a stud and receptor basis. So basically, there are seven different types, and they are, in theory, designed to be capable of creating many different types of structures, including 3D architectural or 3D creations. So
they're pretty cool. I like the hinge aspect of them a lot.
yeah, the hinge. I'm really surprised I'm really surprised that nobody has created these before.
Yeah, it's kind of what I thought when I first stepped up and saw them.
Because I'm planning on patenting them, and I've looked in the patent search boxes, and I haven't actually seen a patent for this particular design.
Oh,
so
well, that's good news for you then.
Yeah, pretty good news for
It's
me.
a lot of work getting a patent. I've looked into doing that too. There's a lot more to it than people think, huh?
Yeah.
Yeah. Well, good luck with that.
Patents right now, though.
Yeah, right. That's the first thing you got to do. Well, good luck with it. Thank you.
Alright, my name is CJ Clark, and this is Spotter. Spotter stands for Seeking People Over Terrain. If you've ever been up in the mountains, you can definitely see that it's really rugged terrain, and if you get lost, it's really hard to find your way back, and it's really hard for people to find you if you get lost. That is this thing's purpose. Basically, it gives the search and rescue personnel on the ground an aerial view of the area that they're trying to search for people.
Aha. So that's really cool. So somebody doesn't have to get up in a helicopter with people that would cost a whole lot more.
Yes.
And sometimes
just
you can
a 10-minute helicopter flight would cost around $2,000.
Yeah.
When this, all it costs is the electricity.
And it can get into smaller places too.
Exactly.
That's great. Well, this is excellent.
Thank you.
All right. Good luck with that project.
All right.
Thanks.
Hi, I'm Duncan Limbo. We've got a couple kinds of cellular automata that are programmed for different Arduinos here. We've got Langton's Ant running on this, some smaller ones with Game of Life and also Langton's Ant, and a big NeoPixel display, which is running a modified version of Langton's Ant.
Wow, these are really neat. They're just a lot of fun to look at.
Yeah. They're really mesmerizing.
They are, especially this one here. All right, great. Thanks a lot.
Yeah, no problem.
All right, Kerry Krause, here with the ACT React Uno Pi exhibit. We're from northeastern North Carolina, out the Outer Banks. Been coming to the fair here for Ben's group for the last 3 years. What we've got going on here is several things. We've got something called the Edubuntu Linux computer that we can use to upgrade XP boxes in the classroom that aren't being used. Usable computers. Of course, somebody was over here playing a game, which is fine. And it has, playing a video there, but it has Office compatible stuff, and this is 4-year support-free software for XP.
Excellent.
Over here we've got a Raspberry Pi 3, which is the latest one that just came in.
Just got one of those myself.
Yeah, that one right there. And it's got Wi-Fi and Bluetooth and stuff on it.
Right.
It's running up to HDMI, so you can hook it up to your TV. A little person was right here playing some games, but the idea here is that it's so powerful you can do a lot of different things on it. There I've laid out a diagram for a real-time clock I got on a Pi down at the other side. Okay. Down there. Now down here we've got a little dolphin which will move. I'm right in its ultrasonic stream, so it's confused right now. But when you're far enough back, the little dolphin, the big dolphin will move based on you. This one, come back up. This is actually the computer that the Brits have for every school student in Great Britain.
That is awesome.
$35. They learn programming, computers, and so forth. Right?
That's great.
This is what the British are doing.
What is the underlying OS that you're using?
What's that?
What is the underlying operating system?
This is Raspberry Pi 4. It's the latest one. So this has got the Wi-Fi on it. It's got the Bluetooth, even though the Raspbian that's on it is not set up for Bluetooth yet. It's low power mode. But I'm just pointing out how fast you can do things with it. Notice I'm going to have it compute a set of fractals and display them on the screen automatically. This is not a movie. It's actually computing these things on the fly using a program called Exo. It's computing every one of those dots and displaying it.
Wow.
That is, for a $35 computer, that is fast.
I forgot, how many megahertz is the processor in this one?
This is actually the ARM processor. It's got 4 cores on it, running at 1.2 gig each. Yeah.
I got the one that's got the Windows IoT on it, so I'm going to play with that.
My next project is to put one in this Hello Kitty box, put a camera there, try LEDs here, so you can have a supercomputer hanging around there.
That's awesome.
Next project.
All right, thanks.
Hello Kitty. Oh, you want to put it back?
We're with Alamance County Beekeepers. We association that helps with the bees in North Carolina, a member of North Carolina Bee Association. We teach classes. They first of the year, 10-week class. You want to become a beekeeper? We'd be glad to have you as a member.
That's pretty neat. That's a good thing, because I know bees are going through a whole lot of endangerment right now from all kinds of things, pesticides and whatnot. I've been reading about it. It seems every other week there's another article out about something that's, you know, bees have a problem, and they're very important, because without them, nothing gets pollinated. They're one of the things that pollinate anyway.
Yeah, every time you sit down on the table, there's something associated with the bees.
Sure.
You're eating.
Yep.
Thank you, Chris. The struggle with the bees are there, but we are doing our best to fight against it.
Well, that's great.
Come here, Randy.
Hold that thing up there, John.
Go ahead. Good. You're on camera, Randy.
Thanks, you guys.
Thank you. Have a good day.
And take this right here. Fold it to the center. Don't go over that line though. Let's take just before you get to that line. Let me look at it. Very good. Now, do the other side. Just the opposite. That side right there. Yes. Okay.
I'm Eric Hart. I'm a prop maker, so I brought some of the props I've worked on. Mix of all sorts of materials: wood, foam, resin, paper mache, metal.
Well, these look great.
I have my book and I have a YouTube channel where I'll do step-by-step showing how I built some of the props and then other tutorials.
Oh, that's great. All right, thanks a lot.
Thank you.
Matthew Huck Creation. Do you have a CNC woodworking machine or do you I'm here at the Maker Faire with the catapult, getting kids engaged and involved with using physics. So.
Very nice. Thank you.
Hi, my name's Rankin, and I have developed a course for small engines called Crankin Engines, no G. And this is just a way that people can learn about small engines and teach their kids small engines very economically.
That's great. Kind of like you and I did in shop class in high school.
Kind of like we did in shop class in high school, or took stuff apart that was the parents that worked, and
that's right.
Either put it back together or not.
Exactly.
So, Dad went on vacation one time, and I took the carburetor off the 56 Ford and took it all apart, and my uncle had a cow when he came into the garage and saw the carburetor all scattered out. But I got it back together and it ran, and Dad never knew until my uncle told me.
And then you knew all about carburetors when you were done.
Well, I knew a little. I don't know about all about, but it certainly stimulated my career, and I became an automotive instructor for 32 years. And
That's
now
great.
I'm retired.
Yeah. So your little demonstration here of compression, could you run that for me one time?
Sure. So I hooked up an electric drill where the blade would be and put a wine cork in the spark plug hole and check compression.
And yes, indeed. We could probably calculate the compression by how high it went if we wanted to get all crazy, but that's another course.
That's right.
All right, thanks a lot.
Thanks, Dina.
Well, thanks for coming. We're at the Burlington Mini Maker Faire. I'm Mark Smith with the Triad Electric Vehicle Association, and we have electric bikes here. I have some materials from a company called Cycle 9, which was in Carborough. They were just an electric bike maker and a repair station until about 3 years ago we went out of business, so we got some of their materials. And we have two bikes over here. One folding electric bike. This is a folding Curry electric bike from 1998. So it has a simple one throttle control, battery pack in the back, and a motor that's on the left-hand drive. And then the hit of the show is my friend Paolo here brought in his electric trike.
Oh wow!
This is really the underpinnings of the Organic Transit Elf. It's the same kind of design. So you can actually ride it, and it has an electric motor here at the front. This is a kit. Slice off the old crank arm and put in the motor, wires, and one throttle switch, and now went in standby mode. There we go. And now it's actually running powered.
Wow.
Instead of me pedaling. The advantage here is when you have a front drive like this, the motor is taking advantage of the gears.
Right.
In most of the other designs, the motor has a separate gearing than you do. So this is a pretty popular design for incumbents now. Probably, I'd say in the electric bike market, most of the high end, or many of the high end, are moving to recumbents.
Wow, it's pretty neat. All right.
Thank you very much.
Thank you.
My name is Charles May from Robot Mustache. We do a collection of wooden robot craft kits. They're all laser cut bamboo. Basically the idea is that you have a little kit, follow some instructions, and piece together your own little posable robot.
Pretty neat. Let's take a look at some of the models here. This is an instruction set. Okay.
And then these are two different prototypes, and these are the actual kits that we're offering right now.
Those are great.
Thank you.
Of course, I want to take one and stick motors in it and make it move. Oh, they're really nice. I love the whole laser cut thing with the nice burned edge. It's a nice aesthetic.
Yeah, it is a nice aesthetic.
All right. Well, good luck with your business.
Thank you.
All right, thanks.
Hi, my name is Fritz. I'm out of Greensboro, North Carolina, and what I do is I make throwaway toys. I take old and broken toys and other found items, and I make brand new characters with them.
That's awesome.
Thank you.
I love that. I love repurposing stuff myself. So.
Yep, it's kind of a creative recycling.
Yeah, that's great. Let's take a look at some of the stuff you've done here.
Let's do it.
Rosca Rangers, those are awesome.
Jamaica's first superhero team.
Nice work. Thank you very much.
Thank you.
These are way cool. 1/24 scale dragster cars. These things are awesome. These go 60 miles an hour, which is like over 1,000 miles an hour if you scale it up. It's crazy fast. These are really nice. Some of these chassis are soldered together. I'm just going to take you down the row here. These are beautiful models. There's one back here that's weathered up all nice. It's like a hit and run.
Squirrel jumped on.
Big squirrel. Really nice stuff.
Love it.
Do a little video?
Yes.
Alright. Some your name and what's going on here. Okay.
My name is Dan Allen. I make the Arduino kit, and it's an electronics prototype and development system based upon the Arduino microprocessor.
These are awesome. They're kind of like the old Radio Shack 101 kit, only a whole lot cooler.
That's kind of what inspired it. I tried to teach Arduino electronics in my classroom, and after we lost all the parts and bent the leads and couldn't identify the parts, I went back to how I learned back in the 80s on the Radio Shack kits with the springs and wires and introduced it to the Arduino, and that's what happened.
That's really great.
So
it's an awesome idea. I see you got a lot of different levels of kits here.
I basically got two different kits. I have a large and a small one, and I just have a couple simple projects built on it, little scrolling lights. Oh, somebody unplugged the wire. It's plug and play wires, so sometimes they get taken apart here. Yeah, I was just controlling the blink rate, the LEDs. I got a Simon game, temperature sensor. You can build all these different projects on them. So you pull out the wires and build different things to it, so it's a reusable kit.
Great, brilliant idea. All right, thanks a lot.
Thank you.
My name is Ben Wiley. I'm a professor at Duke University in the Department of Chemistry. And today we're here to talk about our 3D printing filament that is 100 times more conductive than anything currently out in the market. So it can turn your 3D printer into a printed circuit board maker. So here we have some examples. These three are made with carbon. They're all things you can buy today. And you can see when you hook them up to a 3.7 volt battery, the amount of light you get out. Now with ours, it's 100 times more conducting. So it takes a bigger LED to be able to handle the current that you get.
I see you got the ohm rating here per centimeter.
That's right, 6 milliohm.
Considerably different. Yeah.
So, I mean, there's obviously a lot of applications, and we're just kind of getting started. But there's kind of a 3D printed wearables you can imagine printing on cloth, because this filament is quite flexible. It's not brittle. And yet you can print it with any 3D printer. Like we use a $400 3D printer.
So it's got like similar thermal characteristics and all that?
That's right, extrudes at 180 degrees.
Yep.
And so for something like this, if you, this size ordered from a PCB manufacturer, you get 3 of these for about 50 bucks.
Yeah.
So with our filament, you'll be able to print this for about $1.
Wow.
And this prints in about less than 5 minutes.
This is great. I mean, I would love to do something like this for a lot of the projects I do. I prototype, put stuff together on perf board, you know, old school.
Oh yeah.
And
it's not the easiest.
It's not the easiest. It's okay, but sometimes you get some jumpers that you didn't necessarily want, and then you end up with bad results. But this could be a lot of fun. I can see already for a hobbyist and just prototypers. You know, rapid prototyping applications. This is really cool. It's exciting stuff. I like it.
Thank you.
Yeah.
And it's really easy to put the components on. So we use a solder reflow gun, or solder reflow tool, I should say. Just sends hot air out this nozzle. You can buy one for around $60 on Amazon. And then what you do is you heat up the filament. It gets kind of soft. Then you can place your component there. There you go.
That is way cool. All right, so when you want to give me a free one so I can do videos with it?
Next month. You give us your name and email, and we'll send it out. So we're going to production next month, and
That's cool.
Hopefully,
I'll definitely be looking into that because that's a 3D printer I can get my head wrapped around. Because so far, the 3D printer thing, I've kind of been like, I don't really need one. I can't think of anything I could really use it for other than gimmicks. And I suppose at some point I could. There's people like Robo Girl in Canada. She's doing some really neat stuff with her 3D printer. She's building robots with them. She's designing some really neat stuff, making all the components, putting them together. So she's doing a really neat thing with it. But this is a quick real-world application I could see a lot of hobby people jumping right on.
Yeah, and I think even for starting a business, right? Because like just as one example, a custom LED sign would be $200 to $300,
Sure.
right?
Yeah.
And obviously this doesn't look the best, but once you package it with a diffuser and whatnot, no one will even tell if it's
Exactly. Yeah. Well, this is great.
Thanks,
Excellent.
man.
Thank you.
That's pretty good.
Okay, so we're winding down here at the Burlington Mini Maker Faire. This is which one? How many?
Number 5.
This is number 5, and pretty good day. We had like what, over 90 exhibitors?
Over 90 exhibitors.
Yes. Any idea on how many people came?
I don't really know. Probably at least 4,000.
Yeah, it's
maybe more.
Been big. Yeah. So this is the man behind it all to thank, and all the volunteers, of course. So thanks, Ben.
Well, thank you to all of our volunteers and staff. This year has been amazing because of all your hard work.
All right. Well, so I guess that's about it. And you know what I always say at the end of all my videos? Till next time.
Keep on hacking.
There you go. Oh, wait a minute. It's okay. That'll go in the bloopers section.